Okay, question 11 was asked of me. So that is, let's see here, 11. Oh, I gotta see what QR is first. Okay, so Q to R. Maybe I just need to write them out. Q is 3, 4. R is negative 2, 5. 3, 4. Negative 2, 5. So this is basically a second quadrant vector. What are the components of that vector? It goes left and up. What are the components? Negative 5, right, for the x, and positive 1 for the y. Now, how do we find that when we do this? I might have said it wrong the other day, and I want to make sure that this gets corrected. Okay, if we do terminal minus initial, let's see if we get the correct answer. Terminal minus initial. Because I think I said it backwards one day, and I don't remember if it was 5th or 6th period, so I want to make sure this is right. So from Q to R, and this is Q, and this is R. If I take the terminal, that would be 5 minus 4. That's a 1. Okay, that's good. Negative 2 minus 3. That's a negative 5. Hey, it worked. Yep, I must have said it right. Terminal minus initial. Because that would be, your 5 minus 4. And your negative 2 minus 3. So that's how we get our negative 5 and our positive 1. Well, that's one of the vectors for question 11. Then they want from P to S. From P to S. P is negative 2, 2. So that's right about there. And S is 2, negative 8. Down here, 2, negative 8. So that's like a quadrant 4 angle. So how far to, I know some of you would probably count this, and guess what? It wouldn't be a bad logic right there. From negative 2 to positive 2, isn't that a 4 to the right? And how far down do you drop from positive 2 to negative 8? Negative 10. So that's the other vector here. Man, I do not have enough room here, but okay. And then they ask me to do this. 3 times that one plus the other one. Okay. So I just have to distribute the 3 and add the x's and add the y's. So 3 times negative 5 is negative 15 plus 4. What's negative 15 plus 4? If only we knew what negative 15 plus 4 is. Negative 11. 3 times 1 is 3. 3 plus negative 10. Negative 7. Okay, that makes sense? Yes? No? Kid who asked the question?
Yeah, I'm good.
All right, good. Okay, just making sure.
21.
Just want to make sure that 21.
37.
21 is a. Oops. That's an oof. Sorry. Oh, come on. That was for you over there. Yeah, I oofed. Okay. I know, man. It's bad when you oof all over the place, Yeah, I know. Can't keep hold of any of your cookies. Find a unit vector in the direction of the given vector. Oh, 21. That's a good one. So this is your vector negative 2, 4. Right? Okay, now, What's the magnitude of that vector? Right? You got, come on, little Pythagorean theorem. I got a 4 plus 16 under there, so it looks like radical 20. So what do I do to vector u in order, with this magnitude, to change it into a length 1 vector? What do we say? We took those notes yesterday. How do you make it a unit vector? They want a unit vector. Yeah, you multiply by that. Am I done? Well, according to Staley's logic, yes. Now, if you're in the Math Excel world, yeah, they'll make you distribute that inside there. And you know what? I've heard some of you yesterday saying things like that you liked it better this way. Okay. Hey, man, to each his own on that one. Do what makes you feel better. No, it's just there were several people who said they liked it that way. I'm like, all right, I ain't arguing with you. It's correct. What is the chapter 6? Applications in trigonometry. This particular section is about vectors. Yes? So in other words, they rationalize the denominator? No. I don't see a point to it. I mean, I'm trying to understand if you know what a unit vector is, not can you do basic, simple ratification or taking care of radicals. Okay. Yes, Miss Johnson? 33 and 35. Well, let's definitely look at 33. Maybe we'll save 35 for a moment here. Okay, find the magnitude and direction of the vector. Well, it's probably okay to do 35 too. So let's see here. And I think 37 you're going to laugh at. I think you are. Okay, 33. Okay, so we've got 3, 4. 1, 2, 3, 1, 2, 3, 4. I wish my scale was the same looking size, but it's not. Oh well. So got a 3 and a 4. Find the magnitude. Okay. How are you going to find the magnitude? Seems like a broken record from what we've been doing the last several days or years of our life. Come on, geometry, man. Pythagorean theorem. Oops, why did I put a square? Why did I put a square? Take that out of there. I already squared it. So, square root 25, what do you got there? That is 5. Nice on the magnitude. Now, direction. How do you find this angle theta? Now, it is really cool that it's in quadrant 1 because as soon as I find that angle, I'm done. Inverse tangent would be awesome. Right? So, we do inverse tangent of what? Four over 3, right? Opposite over adjacent. Pull out the handy-dandy machine. Inverse tangent, 4 over 3. And we get 53.1 degrees. Is this the direction, or do I have to do something like subtract it from 180 or add it to 180 or subtract it from 360? That's it right there, folks. We're done. Now, when would I have to add it to 180? If we were in which quadrant? Add it to 180. When would I have to go over here to 180 and add it? That'd be quadrant 3, wouldn't it be?
What if I was taking over here at 180 and subtracting it? Where would I be going? Quadrant 2. What about if I was over here at 360 and I wanted to go down? I'd be down at quadrant 4. So the only time inverse tangent gives me the exact direction is in which quadrant? 1. It is very important that you know which quadrant you're in so that you can decide. That is what? Oh, but you showed it now. Okay. So 35. That was next on our list. Now remember this 3i minus 4j, another way to write that would be what? 3 comma negative 4. These are exactly the same thing. Sometimes I think it's a little bit ridiculous to have two different ways to write the exact same thing, but one is called a linear combination and the other one is called component form, but they mean the same thing. So which quadrant is this in? Don't say the other one. There's 4 choices. Okay? 1, 2, 3, 1, 2. Oh, I'm going the wrong way, aren't I? 1, 2. Oh, I went the right way. Man, I'm doubting myself. Does it matter which way the arrow, which way the point on the arrow is going? I'm glad you said yes. All right. So that's my vector. 3, negative 4. They want the magnitude. Anybody got the magnitude? 5. Good call there. It's a 3, 4, 5 right triangle, and we just figured it out in the last example anyway. Yeah. So what about theta? Little inverse tangent of negative 4 over 3. And what does your calculator spit out? Your calculator spits out negative 53.1 degrees. Give me the rotation in its positive form, please. What's that rotation in its positive form? We're down there in quadrant 4, so we got to take just a few seconds ago. You know, when Mr. Lazar was making fun of me for raising my arms in the air, we talked about 360 over here, right? Now, I'm sorry. You know, it tempts me to do that. Okay, so anyway, you bring that down, right? You bring that 53.1 degrees down in the quadrant. Yeah, just once a day. Keep your clothes on, man. Okay. Yeah, we don't do that. That's bad. Okay, that's how you get fired. Okay, it's 306.9. So please just understand that tangent inverse is fantastic to help you find the angle that you need in order to determine the direction. Okay. Now, 37. Can you look at that and tell me what the magnitude is? Yes? 7! Good job. How about the direction? 135. Man, that was a lot of heavy lifting right there, folks. Okay? When it's written in that form that we have right there, 7 cosine 135 I plus sine 135. I'm going to run out of room for my J. Yeah, they basically handed you the mag and the direction, man. Oh, I thought you were going to laugh, man. I thought you were going to be like, ha ha ha, that was easier than I thought. But evidently not. Okay, yes. I surely can. What do you got for me? Did you snip it and email it to me?
No, I just got it.
All right, well, snip it and email it to me. Okay. What's not fair?
Number 4.
That's all you say. That is on that particular one. When it's written in that form, you're given the magnitude and the direction. So I bet you could tell me the magnitude and the radius of 38.
So it would be 2 and 60.
2 and 60, thank you.
Smart.
See, I love this. Okay.
You're going to have to learn that life is never going to be perfectly fair once discretion.
It's true.
That is true.
I've learned it.
Annotate mouse. Okay, you're supposed to attach it. This is gonna be hard. I gotta. Come on, open it up. Why isn't it opening our picture? I don't know if I can blow this up enough. Maybe. It's not really behaving very well at the moment. Because you'd think this would open it up. Yeah, if you could attach it, just attach it to the email and send it to me. We're burning daylight here, folks. This is a Math Excel question. It looks like 6.1.43. An airplane is flying on a compass heading. Okay, so we haven't gotten to this question. So we're going to save this question and come back to it as soon as we do our notes on this question. To get familiar with what's called the bearing scale. Okay, the bearing scale is not something you're used to yet. You are used to the Trig scale. The bearing scale is used for ships and planes with north, south, east, and west, north being 0. They even go so far as to say they list all their bearings. We're not going to do this, but actual bearings are listed with 3 digits. Bearing 000 would be due north. So if you're watching one of those cool movies where they say something like bearing 020, that's a 20-degree bearing. Okay? They're always listed with 3 digits. This is 90. This is 180. This is 270. Everything heads in the positive rotation is in a clockwise manner. You've got to get this understood. Otherwise, now, vectors, as we draw them, are based on the trig scale. 0 on the right, 90 at the top, and so forth. When we talk about direction, we use the trig scale. When we talk about bearing, and we specifically need to use the word bearing in order to be switching to this scale. If I ask you for the direction of a vector, it's on the trig scale. If I ask you for the bearing, it's on this scale. You have to understand that. In fact, I should probably clear that off, and I should use my, I'll come back to that in a little bit. Come on, I don't need that anymore. Okay, we'll just end the meeting and get rid of that. Okay. So, let me redraw that again since I got rid of it. Northeast, south, and west. Okay, 0, 90, 180, 270. A DC-10 jet aircraft is flying on a bearing of 65 degrees at 500 miles an hour. You notice how they drew their vector. Okay? So when they measured their 65, it's coming from due north. The length of the vector. So they gave me the magnitude of the vector. They did not give me the components of the vector. So if I need the components of the vector, I'm going to have to figure that out on my own. Find the component form of the velocity of this airplane. Okay, so they're basically asking me to come up with those sides. How do I do that?
The velocity of the plane has been given to me. It is the magnitude of the vector. Okay? I need the components. How do I find those components? I heard something over here about a cosine. That's probably a good idea. There's a 25 cosine in the x component. There's a sine 25 in the y component, but we need something else here. 500. Oops, I need to move that bracket over. Oops, I said erase. Folks, all you're doing is using your SOHCAHTOA to come up with the sides. That's it. But I did need to identify the part of the triangle that I was using. And you'll notice that we used what we call the reference angle. Do you know anything about those two sides? Do you know if they're positive or negative? Because of the quadrant, we know they're both positive, right? You have to make that decision. You have to decide based on the quadrant they're in whether they're both positive or one's positive and one's negative. That's true. And those components you probably would need to figure out. You could probably round to the tenths because I'm sure they're not nice numbers. 500 cosine 25. What do we get? 453.2. 453.2. Comma 500 sine 25. 211.3. So something like that. Those are my components. Yes? What, the 500 cosine 25? You sure? Okay. I only put this picture in here so that it would kind of give you an idea of the bearings. So notice that they list them out with 3 digits, 060. I'm not going to do that. I'm just going to say bearing 60 degrees. Okay? But those are the correct looking pictures for those particular bearings. Okay, now. Pilot Megan McCarty's flight plan has her leaving San Francisco's International Airport and flying a Boeing 727 due east. There is a 65 mile per hour wind with a bearing of 60 degrees. Find the compass heading McCarty should follow and determine what the airplane's ground speed will be. Now, the airplane's ground speed, folks, will be the magnitude. So that right there, come on, stop it, stop it, stop it. This is going to be the magnitude. What do you think I'm supposed to do with these two vectors? Add them together, right? I need to add them together. So I'm going to ask for the bearing of this. So we'll be finding the magnitude and the bearing. So what are the components? I'm a little bit confused on this picture for a second. It says that she's traveling due east. Oh, I see. Okay. She wants to go due east, but the plane has to go. Do you see how the plane has to be aimed a little bit southward? Because of the wind. That's exactly right. Because she wants to end up. So if we push, if you said that already, I apologize. But if we take the wind and we add it on to the end, this is what she wants to occur. She wants to be, the result to be from there to there. Okay? So That is the triangle that we're dealing with. She wants to be traveling due east. So they're basically asking me to go a little bit backwards here. Okay? So if you have, can you figure out the vector for the wind? Help me figure out the vector for the wind. If that's a bearing of 60, then what is this angle inside the triangle? That's a 30-degree angle. Okay? So if I want that vector, that would be 65 cosine 30, 65 sine 30. Now, we're going to be adding another vector to this. And what vector are we going to get out of it? That's the question. So there's this other vector here that they've drawn, but we know the magnitude of it is 450. Could we come up with the components of this and this? If we wanted to. I'm guessing we do. So, start thinking, folks. Start talking. Work fast. Now, what do we know about x? Okay, I'll give him that one for, We do know how to set it up kind of like this, don't we? So how would we set it up? We know the hypotenuse is 450. 450 cosine theta. That's about all I got. What would you say for the y? 450 sine theta. Because we just don't know what theta is. Now, what part of that green vector do you know? Do you know the x or do you know the y? What part do you know, the x or the y? I have no idea what the x component is. But I do know what the y component is. Do you? 0, thank you very much. Look at that vector. It goes directly to the right and never goes up. That's how she wants the plane to go. She wants the plane to go due east. In other words, no vertical motion up and down. You're right. I have no idea what's going on over here. Well, guess what? Is that something we could figure out? I bet we could set up an equation and solve it. So I gotta lock it in place. 65 sine 30, I bet we could figure that out. Plus 450 sine theta equals 0. Solve it. Yeah, go to lunch. We'll solve it when you get back. We will finish this problem, and then Ms. Koob will help you with yours. Okay, so 65 sine 30. What you got there? 65 sine 30. 32 and a half. That's right, because the sine of 30 is 1/2. That's nice. Okay. So if I, let's see, put that 32 and a half on the other side, right? So that would be 450 sine theta. Yeah, you should write this down. Negative 32.5. Then what? Yeah, let's do some division. Divide by 450. Okay, so now sine theta, so we're dividing by 450. What do we get for theta? Theta is 4.14 degrees. Oh, I didn't get negative. When you inverted the sign? Oh, I forgot the negative on the 450. No, there wasn't. I had a negative. Oh, I forgot the negative on the 32.5. That's why. Okay, okay. All right. Now, so that should have been negative, and now I get that. Okay. So, how do you find the x and the y components of the blue vector, the 450 vector? How do you find this vector? Come on. Do we want, maybe I should ask this question. Do we want to find, let's see here, find the compass heading McCarty should follow and determine what the airplane's ground speed will be? So they want two things. They would like this bearing. Okay, so can we find that? What's that bearing? Or I don't even know if I need that, maybe, but her bearing should be what? Okay, it's got to be past 90, right? 94.14? That's a good bearing right there, 94.14. Now, that answers the overall direction she should head. But it doesn't answer the second part, which is the ground speed of the airplane, which is the length of the green vector. I still don't know. You guys still haven't told me how to find that second vector completely. It says 450 cosine theta. What's theta? Oh, negative 4.14. Hey, plug it in. So 450 cosine negative 4.14. 448.8. Okay, 448.8 and 450 sine negative 4.14. Yeah, negative 32.5. Of course, we got the first vector, and we can add those together. Everybody in the room knows what zero's that one. What about this part? So I really need to focus on the 65 cosine 30 and the 448.8, right? Because those are the x components of the two vectors that are getting added together. 65 cosine 30 plus 448.8. 505.1. Okay, this is the ground speed. What was your question? What's your question? Come on, I hear you. Okay, remember, we are going to be adding these two vectors together, right? We knew that the y's added together to give us 0, based on the picture. We were trying to find what the x's would give us. But we didn't know what the x's would give us at first because we didn't know what theta was. So the first thing we did was we found theta, negative 4.14. Then we could go back up and plug it in to find out what the sum of the x's would be. Right? So we added the 65 cosine 30. And we added the 450 cosine negative 4.14. Those two things added together gave us the 505.1. They were the x components. Okay, now let's see if we can pull up that question you asked about. Is this your question? Yes. Airplane is flying on the compass heading bearing of 340. Okay. I have a feeling this is going to be an easier question than the one we just did. Okay. So if the plane, let's get the draw tool, shrink that down, go with red. Why isn't it drawing? What am I doing wrong here? All right, well, we're going to abandon that, and we shall take care of that. You're not going to trick us. Okay, so if the plane is heading at a bearing of 340, that's got to be something like this right here, right? Because right there is a bearing of 340 degrees. 0, 90, 180, 270. If I draw this triangle in from here to here, can we find the components of it? Well, do you know this angle down here? Do you know the angle in the triangle called the reference angle? It's got something to do with 340 and 270. Subtract them, right? So it's a 70-degree angle right there. So we know that the magnitude of that is 315. So this would be 315 cosine 70, 315 sine 70. Are either one of those negative? One of them is. Which one? Well, look, you're going left and up. Which one of those is... you should have meant net cosine. That's right. Right. What about the other one? The wind is blowing with a bearing of 320. Okay, so it's going at 320, so something like this. I think I'm exaggerating that a little bit. It's got an x and a y component, but it's got a magnitude of 20. So that would be something about 20 cosine something and 20 sine something. Are either one of those negative? The bearing is 320 degrees, so we're definitely in that quadrant 2. Okay, wow, folks. 320, something like this. Draw the triangle. If this is 320, what's the angle down here? Come on, that's 270, and then it goes up to 320. 50. Thank you very much. Okay. Are either one of those negative, x or y? The x is. Thank you very much. Usually the x is negative, unless you ended things on good terms. Now, yes. So I don't starve. That's why I eat. What are we going to do with these two vectors? Add them together. So you will need to figure out what their sum is by adding the x and the y components. Okay, so the first part of this Math Excel question was find the component form of the velocity of the airplane. Well, that's what you would get down here, whatever those two things are. And yeah, they're going to ask you to round to the nearest tenth. And then, now that's interesting. If you look at part A, the question says, find the component form of the velocity of the airplane. But when you look at the answer for A that was copied and given to me, it says the velocity of the airplane. So that's a little misleading. They do want the components because they've listed it with the x's and the y's, but then they said the velocity of the airplane. That almost sounds like the magnitude. Well, the actual ground speed and direction of the plane, so then they're going to ask me for the magnitude and the direction, which is what we've talked about earlier with the Pythagorean theorem and the inverse tangent. But you really need to find these two components. Okay, I'm guessing that you're going to get something that looks like this. And of course, that's going to have a negative x and a positive y. And you'll be able to find the magnitude by doing the Pythagorean theorem and inverse tan to find that angle. Now, is your angle of direction going to be more than 270 degrees? Yes, it will be. I'm guessing since they're using bearings that their answer is also going to be in bearings. I would hate for them to do some kind of nasty trick and not want it in because it says direction, but I'm hoping that they mean bearings just like the originals were. Okay, I'll let you guys go on to your other stuff. It doesn't matter, some of you already are.